And we're live. Welcome to the Evidence and Reasons for the Christian Faith video channel. For those of you who joined us for the talk on the end of the world with S.J. Thomason, we're going to talk about kind of the ideas for the beginning of the world, an origins theory that is kind of, the idea within the young earth creationist community that the world is less than 10,000 years old. There are some viewpoints that say that the fossil record and life are young, but maybe the earth and the universe are old. That is one form of young earth creationism. It's one that we might find a lot in among the Seventh Day, those who profess the Seventh Day Adventist faith. Among people who are like Baptist, other kinds of evangelicals, even a few Catholics, there's the idea that the entire universe could be young. And this poses a problem for the young earth creationist viewpoint. The reason this is of interest to Christians, let's say that there is even a small chance, like say 10% chance, I'm just picking that number, that we begin to find scientific evidence that the universe is young. This would lend credibility to a literal reading of the genealogy of Jesus Christ in Luke chapter 3. In fact, that's my favorite passage in the whole Bible, because it makes a very bold historical claim that if it is on the provision that one reads it literally, and to the extent that observations and theory eventually converge to the conclusion that the universe is young, this would tell me then that that passage is divinely inspired, and by way of extension, the whole Bible is inspired Word of God. Now, clearly people can believe that the universe is old, and even that evolution was the mechanism God used to create life. For those individuals, God has done something to put faith in their heart through other means. For example, it's my understanding that Hugh Ross had become a Christian, and he even heard the Lord talking to him directly. There are old earth creationists who have experienced the healing power of God in their lives when they're at the brink of death. And so I totally respect that it's not necessary to believe in young earth creationism to be a Christian. But if one believes that the evidence points to a young creation, it naturally follows, for the most part, not exactly, that one will accept the Christian faith. One notable exception would be the Jews who are also young earth creationists. And in fact, there is one form of the Jewish calendar that where they count up from the world beginning at some time around 6,000 years ago. It's close, but not exactly to what the evangelical Christians consider the age of the earth and the universe. So this is of interest to me, this topic, but really it is tied to one big event claimed in the Bible, if you read it literally, and that's Noah's flood. So the interest in this whole thing about, are the fossils really in the fossil record generally the result of Noah's flood or not? Was it through millions of years that the fossil record came to be? Or was that through a global flood event? And for the record, I used to be I was a Christian, raised in a Roman Catholic home, became Presbyterian. I started out as a theistic evolutionist, and then became an old earth creationist, and now I'm a young earth creationist. So I'm just going to lay out the theory of young earth creationism, the various ideas within young earth creationism for how we can, resolve what is known as the distant starlight problem, and we'll cover that. And one of the theories within one, not the only one, in
Sal?
young earth creationism is variable speed of light. So Benrex, if you'd like to introduce yourself or say something, go ahead.
Yeah, I'm Benrex. I'm a Christian. I'm agnostic on the age of the Earth, but favorable towards the young Earth creation. And Yeah, that's about everything. And I have a small question about your introduction into that field. Isn't there also a place in the Bible, a verse somewhere where when the end times comes, we will see stuff in the stars? I forgot what it is, but I've heard you quote it some
Oh
point.
yeah, I'll quote, since you brought it up, why don't I play the passage again? I'm not trying to be, have you ever watched Star Wars?
Partially, not everything.
Okay,
A long time ago.
okay, so let me play that passage. It's from Revelation chapter 6. And I'm going to have a famous character read it by the name of Darth Vader. I'm going to have to mute both of our mics while I play it, though, and then I'll unmute. So I'll play that passage.
And white robes were given unto every one of them, and it was said unto them that they should rest yet for a little season, until their fellow servants also and their brethren that should be killed as they were should be fulfilled. And I beheld when he had opened the sixth seal, and lo, there was a great earthquake, and the sun became black as sackcloth of hair, and the moon became as blood. And the stars of heaven fell unto the earth, even as a fig tree casteth her untimely figs, when she is shaken of a mighty wind. And the heaven departed as a scroll, when it is rolled together, and every mountain and island were moved out of their places. And the kings of the earth, and the great men, and the rich men, and the chief captains, and the mighty men, and every bondman, and every free man, hid themselves in the dens, and in the rocks of the mountains, and said to the mountains and rocks, Fall on us, and hide us from the face of him that sitteth on the throne, and from the wrath of the Lamb. For the great day of his wrath is come, and who shall be able to stand?
Okay, so that was the passage in Revelation chapter 6. So the last book of the Bible is known as Revelation or the Apocalypse. And various people have interpreted it one way or the other. I tend to just read it kind of sequentially in terms of events. And in Revelation chapter 6, it talks about the stars falling to earth. Now, that was a hang up for me as a Christian because I knew the stars are way bigger than the earth. So there's no way the stars could fall to earth. I will point out someone named Harold Camping actually literally thought that was going to happen that way. And I'm just like, dude, you're out of your mind. That's not going to happen. Now, in the Bible, it uses the word two. It's the Greek word EIS, epsilon, iota, S, whatever, could be zeta or something, I don't know. But it can also mean toward. So there's the tax collector who raised his eyes toward heaven. It's the same word, EIS. So it could mean that the stars move toward us. Now, Big Bang cosmology is saying that the stars are moving away from us. If we suddenly see the stars move toward us, that would tell us that the laws of physics are kind of starting to fall apart and the cosmos is starting to fall apart. And so we hear about the stars moving toward us. Now, the reason I say it doesn't land is if you go to other parts of Revelation, it still mentions the stars being in the sky. So that's why I interpret it, the stars moving toward us. And after that happened, all the people on earth, from the great or small, started to say, let the mountains fall on us. Let the rocks, the mountains fall on us to hide us from the wrath of the Lamb and he who sits on the throne. This will be such a powerful sign that coincides with this prophecy, that the way that I read chapter 6 is that this is what causes people to get on their knees because they recognize this is the sign from the Christian God. And so this raises the thing about variable speed of light, both for the young Earth origin and then for the end of time, how we can see events from all the stars from various distances all at once move toward us. So that's just a little bit of where we're going. But before I go there, I'm going to talk about the distant starlight problem, and then we can talk a little more. You can ask some more questions, and I'll take some questions from the side chat. I'll try to monitor it. If we say that the universe is old and that the stars are very, very far away, we usually state very far distances in light years. That's the time it would take a photon of light to travel from one point to another. So if something is 13.4 billion light years away, it's going to take 13.4 billion years for that photon to finally reach us. And that would mean that the universe would have to be very old. And that has been probably one of the two biggest thorns in the young Earth. If people believe in young Earth creationism, from what we know about how physics works, and subject to change, obviously, but for right now, our understanding of physics is in conflict with the young Earth and really more literally the young cosmos viewpoint, and so that's basically the distant starlight problem. The second problem is radiometric dating, and we covered that. So
yes.
I'll take questions now.
I was responding to, how is his name pronounced? Wesley or?
Wesley?
Wesley. Okay, Wesley. That was a response to his comment.
Okay. So we should consider that the author is writing from his point of view and is using the best language he can afford to describe the events, as I understand it. Well, I would say at this point, anyone's guess is as good as anyone else's, because no one agrees on how to interpret Revelation. But I'm just pointing this out. I've tried to point it out to young Earth creationists. I said, have you bothered to account for how we're going to see distant starlight in the future in light of Revelation 6? And so some of these models don't accord with this part of the scriptures. And I said, okay, maybe, granted, this is a theological viewpoint that you're trying to come up with compared to your scientific viewpoint. If you just accept theologically that this is a claim about the future and how light should behave, then if your particular solution to the young cosmos distant starlight problem doesn't account for this, then maybe it's wrong from a theological standpoint. So
yeah, the way I heard this passage being explained is that that this isn't about literally the stars, but either powerful people or powerful spiritual beings. I don't know. I always avoid future predictions because only when God reveals them will we actually understand them. And so I just restrict my search there to the minimum facts which are actually relevant.
Oh no, that's totally fine. But what struck me about this was right after this big earthquake and then things happening in the heavens, and then Jesus said at the end there'll be signs in the moon, in the sun, and in the stars.
Mm-hmm.
And I think it's also describing this. Jesus said that, and men's hearts will be fainting from fear. And then you see also in that passage in Revelation 6, right after this, that's when people get on their knees. I don't know that, if we saw a meteor shower, yeah, maybe some people get on their knees. But it's talking about the small and the great finally getting on their knees, or really actually begging the rocks to fall in. That's a figure of speech. They're so terrified about what's going to happen to them. Now in the Old Testament, great miracles were worked where Elijah was calling fire down on people, and that was really scary. And God worked a miracle of fire burning up like an altar with sacrifice. And so for just a brief moment, people did all bow down to the Judeo-Christian God. But within maybe not even 24 hours, they turned back because Jezebel was able to recruit people to try to go kill Elijah. So that's why I think the stars falling toward Earth like a fig tree shaken of its leaves. I think that's the sign that will make people just briefly come to their senses and please, start trying to shield themselves from the wrath of God because they know now the judgment is about to happen. So if one doesn't interpret it that way, I respect that. But if one does, then this will have a bearing on young Earth cosmology.
And
So,
by the way, I don't say my position is correct because I'm aware that my position I hold here has the risk that people who hold that view always switch to, yeah, that was metaphorically and that was cultural back then. And so it holds that risk. And I think it might be appropriate. In other places, I wouldn't say so. But I also, for example, one miracle I think is literal is where how is he called again? The guy after Joshua, after the guy after Moses. He was battling a war and prayed that the sun would stop moving, and it did. So I think that happened literally. So, and that is, in my opinion, that's the biggest miracle which happened in the Bible, next to the creation of the universe itself.
you raised something very interesting. A lot of creationists don't know how to deal with that passage, myself included. So I'm right, that's a very, very interesting point. And I'm just going to confess, I don't know how to resolve that from the physics that I know. Now, Wesley had said it could be a nuclear war, actual stars, or anything else. But what I want to say is, okay, if we had a nuclear war, are people going to start bowing down to Allah? Or are they going to, just think this is just terrible? This is going to be a sign that specifically points to the Christian God. And that's why I think it's not just going to be bad. People will be bowing down and saying, hide us from the wrath of him who sits on the throne and from the Lamb, which is specifically the Christian God. Of course, then they just fall apart and reject, most of the world will reject him. So I could be wrong. And I'm just, if you could just kind of, for the sake of argument, for some of the things when I talk about variable speed of light, we could go there. I mean, you could reference this viewpoint.
I think you have a point that it should actually point to the Christian God, but I also think that James Tour is correct in that he says that each person has Jesus being risen from the dead is written on each person's heart, and he says when he says that each week he invites he basically gets people to call him who want to ask him why he's Christian, and the 90% of those convert to Christianity. And the reason is because, for one, he is getting the low-hanging fruits, like he says, and also because that Jesus dying on the cross and rising again is written on their heart. And so perhaps if it really push comes to shove, then I don't think it's the intellectual side which convinces them. I think it should have to be correct as well, but it isn't the intellectual side which actually convinces people to lie on their, to bow down.
So before we move forward, I'm just going to say hi to people. We'll say a quick prayer. Patrick Alexander, greetings. And of course, Benrex, and then Justin. It's it. And Wesley Coleman. Mr. Jetty, God bless you. Bread of Life, Rebecca. And Mark O'Connell. Mark, great to see you as always. It says in the Bible, acknowledge him in all your ways, and I would like to do that now. Our Father in heaven, hallowed be thy name. Thy kingdom come, thy will be done, on earth as it is in heaven. And Lord, we dedicate this stream to your glory and your honor. Be with us in our conversation as we ponder your word, especially the book of Revelation and the book of Genesis. And even though we may not be able to resolve all the questions we have today, you had said that blessed are those who hear this word of the prophecy. And so with that in mind, we are trusting that we will be blessed just to consider your word, even if we don't totally understand it. And be with the believers here, as some of those, like Benrex, are from far away from where I live. And
Switzerland.
Be with us, Lord, in Jesus' name. Amen. The question came, is this Restream? Restream is the name of the system. So there's like Streamlabs, StreamYard, Restream, YouTube Live, and there are any number of other systems. But this is a live broadcast. So in the last few weeks, we've been definitely covering things that are problematic for the young Earth creation model. And I covered some of them with radiometric dating. And a lot has happened since the time I looked at it in detail from 10 years ago in my graduate solid state physics class. We know now that there are processes beyond radioactive decay that can change nuclear structure. Whether those processes can account for the appearance of age, we don't know yet, but I had covered numerous processes where earthquake, tectonic activity can create enough electricity to possibly, and strain, mechanical stress and strain that may be able to change nuclear structure. Now that was outrageous even as recently as 10 years ago, but there have been a lot of experiments that is making this it's becoming an exciting possibility that nuclear structure can be changed at low energy given the right conditions. And that was the topic on the heavy electron quasi-particle model of low energy nuclear reactions. So if you look back just maybe a couple weeks, you'll see the stream on that. The stream on heavy electron quasi-particles changing nuclear structure. And that was a fun read. Recently, I've been exploring, I've always been, ever since for like the last 20 years, began to be very skeptical of the Big Bang. I'm more so now. I have been in contact with 2 plasma physicists in light of what I've been reading this week, and I may be making a decision whether to go back to graduate school for a 6th science degree. And it's going to be probably this is possibly, I'm facing one of the biggest decisions of my life. Of course, it would be great to just study physics in and of itself. But if it can support young Earth creationism, all the better. I have found some really interesting phenomenon where what they call plasmas, free electron plasmas in space can cause what they call a redshift of light. And if that is true and it can do it enough, that would imperil the entire Big Bang industry. And so something could break sometime. And people are saying that's not the mainstream. It's like, well, it depends on how you define it. There's a minority in the mainstream, including professors at my school, that are sympathetic to the view I just articulated. So it's like, well, who am I going to believe? Because these are also really smart guys too. They just happen to be only in the minority. So, but today, okay, so, but if we destroy the Big Bang, old Earth creationism and young Earth creationism could still be true. If we assume, just for the sake of argument, if we assume young Earth creationism is true, we have the distant starlight problem. And that's one of the two biggest problems to deal with. So if you have any thoughts, and then I'll just kind of try to lay this out for what the variable speed of light theory is. If you have any comments or questions here, Benrex.
No, I'm just curious what those theories are.
Okay, so I have an informal list here of, and I apologize for the font, they're like 14 different young Earth creation cosmologies to account for distant starlight. And I apologize for the font, but I'll just read it. And some of them are better developed than others. The first one that was proposed is created light, that God just made light in transit. So the light from 14 billion years ago doesn't have to be a problem. God just made photons, kind of already on their way. So that's called created light. There are theological problems with that, but we'll just move on. CDK, the idea is put forward by Barry Setterfield that the speed of light was a lot faster in the past. And now it's slowed down. There was something by Russell Humphreys that used general relativity called white hole cosmology. He had version 1, which he rejected. He worked on version 2. I don't know if he's rejected it yet. There's a fourth one called Carmeli Cosmology by John Gideon Hartnett. I mentioned him before. He's a very, very accomplished physicist, but he retracted his idea on that. Jason Lisle put forward the one-way speed of light. He was president of the Institute of Creation Research. There's this alternate electrodynamics by Bill Lucas. There's this thing called Advancing the Time of Space-like Hypersurfaces. That's General Relativity by P.W. Dennis. P.W. Dennis is, by the way, he worked for NASA. He won awards, respected scientist, respectable credentials in general relativity. There's another theory by Teneb, Baumgartner, and Ostermeyer. These are respected young Earth creationists, called the creation time coordinate. I think Danny Faulkner, it's not really a well-developed theory. It's the idea of instantaneous light travel, except here near on Earth. I don't recall the authors. There's one sort of strange geometry of the universe that somehow solves this. There is the Gerald Schroeder. He's a Jewish nuclear engineer, MIT PhD, and he's a Jewish young Earth creationist, and he uses general relativity, and his solution was put forward in at a talk he gave at Azusa. So I'm calling this the Azusa theory. My theory is temporal spatial variable speed of light, a new ether, and neo-Lorentzian relativity. So if you ask me which one I think is the best, obviously mine, but I could be dead wrong. What I do want to point out, however, is, so we have these 13 theories. As a matter of principle, at least 12 have to be wrong because they all can't be right. And it could be they're all wrong. So this is where it gets a little difficult. I have,
Sal?
yes.
Could you, if you probably know all of them at least superficially, could you like mark those you think are most likely wrong? Like you
Sure.
just think, yes.
Sure, I'll tell you which ones I think are most likely wrong.
The retracted ones, probably.
Yeah, definitely the retracted ones. Let me see if I can. Yeah, so okay. The created one is not testable, but there are theological problems with it. So I'm going to just say that is not a scientific theory. I mean, it could be true, but it's not scientific.
That's also my opinion.
Okay, so let me just go through all of these and tell you which one I think needs to be taken off the table. So I'm going to take this one off the table. The other problem with this is if one reads Revelation like I do, then it's incompatible with how light will behave when the stars fall toward the earth. But then other people don't share that theological view. I'm just pointing out, for me personally, that's just not going to work.
Yeah, and the thing I have a problem with is like uh, when God creates a fake history which doesn't exist. That's what I have a problem with.
Exactly. So CDK, I'm not going to take that totally off the table because it's close to mine, but I know Barry Setterfield personally, worked with him. I had to sadly reject his version of changing speed of light, which is CDK. So I'm still going to leave it there because I think he may or may not be in the right direction. He's saying that the speed of light all across the universe changed and it slowed down. But I'm going to give him half credit and say he has maybe the right idea that over time, the speed of light in some places in the universe, rather than all places, could have changed. So he says all over. I'm just saying maybe just in select parts. So I'm not going to throw that. I wouldn't put that in the category totally wrong. Since Russell Humphreys got rid of his own theory, I'm going to put him in the rejected. Now, Russell Humphreys is a PhD physicist, but he worked in heavy electromagnetic stuff. But P.W. Dennis is actually a specialist in general relativity. And I wrote to Dr. Dennis this week. He rejected Starlight in Time. He said there's an error, and he cited one of the books I had in graduate school, Thorne, Misner, Thorne, and Wheeler, and he said it's right there in the book, and you can reject it. And I said, okay, that's textbook. I'm going to go with the expert, Philip W. Dennis. The Carmeli Cosmology has already been retracted by Hartnett himself, so I don't have to go there. The one-way speed of light, it's not, there are some, okay, let me just say, there's Jason Lyles. Yes, it is Kip Thorne. Yeah, Kip Thorne, Nobel Prize winner. Wheeler had 2 Nobel Prize winners that he taught, including, I think, Weinberg. But anyway, yes, it is Kip Thorne. So there's the internet version. I think one promoted by some guy who's a used car salesman who dresses up in a Superman outfit. You can actually measure the one-way speed of light. There's a publication by Luke Barnes, The One-Way Speed of Light in a Milne Universe. And he pointed out if it's not a Milne universe, you might be able to detect it. The other thing is muons, and I have a letter out to some people. Muons experience time dilation depending, they experience time dilation. So if there's one-way speed of light, a muon flying one way will travel farther than the other because the muon decays. So there is a way to measure it, and the fact that it keeps being promoted that it's unmeasurable, I'm going to have to reject that because it is measurable.
What is a Milne universe?
Milne, M-I-L. Let me put that in the chat since some people would be curious enough. So there's a free version of this, and then there's the one that ended up in peer review. Obviously, they may not be exactly the same. Luke Barnes, I covered his work recently. He had the Cosmic Revolutionaries Guide, One Way to Beat the Big Bang. He's a professional cosmologist, professional physicist, professor of physics. He's very well qualified, very well respected. He's a devout Christian. So The fact that he posted this and examined it, very respectable. John Hartnett also looked at the one-way speed of light. But I'm just pointing out that it is measurable. It should be, unless you're rewriting some parts of relativity, which one-way speed of light is like, well, yeah, maybe.
I also have a question about the one-way speed of light, in which is the direction that speed of light is. I mean, if it comes from Earth and goes into space, that's the direction where it's speed of light, or if it's always north-south, because that makes a difference.
Oh,
Uh,
absolutely. Good on
because
you.
because when it's always, let's say, north to south, then we would immediately see the stars falling on the north side, and we wouldn't see the stars falling on the south side of the hemisphere. And if it would be from the Earth going away from the Earth and then coming, it's just if the Earth is the center and there is the speed of light, then if you make a triangle, then you could basically measure that the speed of light is different. I
Yeah.
mean,
Yeah.
I mean, going back to going away from the Earth would be, let's say, instantaneous. Then going across this, parallel to the Earth's surface would be, I have no clue what speed. And then going back again would be twice the speed. And then, okay, I think I found this, how we couldn't measure that. If the speed parallel to the Earth's surface is one-way speed of light, going away from Earth is twice the speed of light, and going back to Earth is instantaneous, then we couldn't measure that.
So I don't know what to do with this, but I said, one, the supposed the Earth would have to be sort of almost like the center of the universe, where the one-way speed of light just points toward the Earth.
Yes.
And so as the Earth is orbiting the sun, the one-way speed of light has to be adjusting across the universe. I have problems with that. And as I said, depending on how it's implemented, the muon decay, it has finite time. The reason the muons are able to reach the Earth's surface is because they're going a fraction of the speed of light. Therefore, they experience time dilation. So their clocks are slower, and they're able to reach the Earth's surface. So we actually have a way of saying, okay, if the muons travel farther distances before decaying in one direction versus the other, then we can have one-way speed of light. And so I'm rejecting. I think I think we're kind of in agreement. There are a lot of problems with it, and
Yes.
there are a lot of there are creationists that are not enthusiastic. So going back to the list, I'm just going to knock that one off. So I'm leaving Barry Setterfield's there, and I'm just going to put like I don't know if I could show it here. Half good. Alternate electrodynamics. Okay, so this relates. Let me just briefly here. We have, let me see, Maxwell's equations of electrodynamics, and I'll show it here. So this is our field of electrical engineering would not exist without Maxwell's equations. I mean, modern electrical engineering. So this is Maxwell's equations.
Although I never used them, but yeah, next.
So, all right. From Maxwell's equations, you have something called, okay, you could barely see it here. You have this epsilon naught, and you have this mu naught. So Maxwell's equations need those two terms, epsilon naught and mu naught. And these are properties of space, and the speed of light can be expressed in terms of epsilon naught and mu naught. And I don't know where it is here. Do they have it here? Permittivity. Hang on. Okay, so the vacuum permittivity, and then there's that mu naught, and you can calculate the speed of light just using that. And I don't have it handy exactly where they did it. Oh, there it is. Speed of light is 1 over the square root of epsilon naught and mu naught. So the reason that I think if we're going to invoke variable speed of light, we have to reconsider rewriting electromagnetic theory too. I don't know how electrical engineering could be done in that case, but I'm going to give, there are parts of Bill Lucas's stuff that I didn't like. They were ad hoc, and it didn't have experimental evidence to date. I looked at some of the experiments he tried to cite, but he has kind of the right idea. You do have to account for changes in electromagnetism. Now, the next one would be P.W. Dennis. He definitely in play. That is, he's a member of the American Physical Society, published in their prestigious journal on relativity several times. That qualifies him in my book. That means he's a respected secular scientist in the field of relativity, and automatically that would make him, he should be respected in the young Earth community. And he found some solution using Einstein's field equations where there's advancing time of space-like hypersurfaces, and he justified it mathematically. Whether it's right or wrong, at least he's getting the math right, and he obviously understands the concept. And anyone who could read Misner, Thorne, and Wheeler's book is pretty bright, because I struggled through it when I was studying general relativity. I only read just a few pages of it and then gave up, related to an assignment on something called killing vectors. Oh man, killing vectors. Killing vectors were killing me. So, so I would put him at 90, I'd put him at kind of the 90 percentile. Obviously this can't possibly, my percentages can't possibly work, but I'm just saying, as far as due diligence, he's way up there. Okay. So he would retain for a long time. This one with creation time coordinates, I'll tell you something that happened at ICC 2018. Tikhomir Tenev, Baumgartner, and Hostermeyer presented first. Then they heard P.W. Dennis, and they said, "Will you be our teacher?" And everyone was like, P.W. Dennis knows what he's talking about. So I'm going to put it as, I don't really want to remove them, but because I interpret Revelation a certain way, it doesn't account for the end. So what P.W. Dennis did, I asked him, okay, would this account for all the disturbances in the heavens that we could see from far away? He said, yes, this model will account for that. So he's better than Barry Satterfield's here, just for that reason alone. Instantaneous time, light travel, I'm going to have to take that off, because we know light isn't instantaneous. I don't know. And I don't know for sure what Danny means by that, but he has said that before, and I don't know how you can justify that, given we have obviously finite speeds of light that are measured. He's a professional astronomer, so I give him credit for that. The strange geometry, I'm just going to take that off the table. I've seen it float around. I don't even know who the authors are anymore. Gerald Schroeder's solution, it's one that tries to say, okay, time flows differently in all sorts of places. Maybe there's just some way that this could be solved. I don't really understand how he solves it, but he's Jewish and very smart, and some of what he said seemed reasonable. So of course, obviously, since this is my pet theory, the temporal spatial variation of the speed of light, new ether, neo-Lorentzian, these are terms that come up from other people, and they have experimental evidence. So I'd say that's 1, 2, 3, 4, 5. I put 5 in play at this point. And so since you asked about variable speed of light, I'll talk about it today.
Yes.
So if you have any comments or questions.
No, not really. In the chat, I just noticed a lot of them are more like old cosmos or just God created the light on the way here. So that's obviously you agree with, you disagree with it, and I disagree with the light created on the way, mostly based on philosophy and not on theology, or just a mix of between those two, not from the strict Bible reading. So I don't say I'm not confident in that view. I just think it's not likely.
So there was a question about interpreting Genesis, and so many people interpret Genesis in so many different ways. And I think the way to settle it is the Lord has to provide some indication through physics what the right answer is. So that'll help us. So like, for example, just like it used to be people and still do believe in naturalistic abiogenesis. But as we found out more, we have more people like James Tour that are saying, well, there's problems with assuming that, and we certainly haven't come anywhere near proving it. And therefore it becomes more believable to think God worked a miracle to create at least the first life. So it's like, okay, just for that, just from hearing James Tour's lecture alone, I would be willing to be an old earth creationist and say, okay, it's not exactly the timeline of the literal reading, but the sense that God worked a miracle, I'd be okay with that. And so I think this is how it's going to be settled, not by any more hermeneutics. Because if hermeneutics could settle issues about theology, we'd settle it by now. Because certainly we don't have, I just wanted to point out, in mathematics, we don't have these sort of arguments. It either is this or that. Either the theorem's correct or it's not. So anyway.
By the way, I read Stairway to Life, and I think one of the best emotional arguments for atheism is like the trend of science argument. They can just list a few things which got more explained by secularism, and then they say, okay, everything is explained by secularism, which isn't actually an argument, like a correct argument, as in mathematically or logically correct, but it is emotionally very strong. And I liked that the Stairway to Life argument, they started their book by bringing a counter argument to that. Like in the time of, I think, Aristotle, they thought like creatures can just appear out of nowhere besides the large animals. And then they said, okay, now mice can't appear out of nowhere, but insects can. And then, oh no, insects can't appear out of nowhere, but bacteria can. And now we say, no, bacteria can't, but far in the past, or perhaps on a different planet, single cell organisms can appear out of nowhere. And so this is a trend of science which gets pushed further back. And I thought that was very good to hear, because it pushed back against one of the strongest emotional arguments for secular atheism.
I've been, as we were going through this, I was hurriedly trying to get the rest of my slides queued up. So let me just point to a Wikipedia article. We won't go into it much, but there is a reason variable speed of light began to happen in the secular world. So when I say variable speed of light, this wasn't owned by creationists. This is actually started by the secular science community to solve problems in the Big Bang. because people were unhappy with the inflation model to account for what they call like the smooth, nearly isotropic temperature of the microwave background radiation. And what was the other one? Magnetic monopoles is one of the reasons. And then there was the flatness of space. And at least for the temperature problem, I don't know about the magnetic monopoles and the flatness of space. The variable speed of light could solve that. So variable speed of light started to be proposed, and it may start to become a little more fashionable now that people like Roger Penrose are disputing inflationary theory. So inflationary theory says that the early moments of the Big Bang, the universe is expanding at thousands, millions, or some factor of the speed of light, which is very problematic, because how are you going to prove that, for one? And that just feels kind of uncomfortable. That, you know, it looks kind of ad hoc. And when I heard that, I said, you could just believe anything. And if you can't even, you know, if you could just postulate something and there's no chance of even proving it, I mean, is that science? You could postulate all sorts of things. And that's, some people got uncomfortable with that. I'm not, and then so people said, okay, instead of moving, you know, inserting space at, that effectively, not, you know, moves objects at millions of times the speed of light away from each other. It's a matter of semantics whether it's moving or not. Okay, guys. But the point is, you have two objects. Suddenly they're farther apart, and you'll say, "Oh, that's just an expansion of the scale." You know, you're not getting it. So I'm just like, okay. At one point in time, they're this close. At another point in time, they're that much farther. Okay. Just ordinary language, you're saying they've moved apart. Granted, they've not experienced acceleration, but they've moved, you know, in that sense, they've been moving apart. And if you're talking about the stars moving away from us when it's really, you know, the scale increase, it's just like, it's just playing semantic games. People will use that against me, and I think it's kind of a petty criticism, word mincing to try to make it seem that I didn't grasp what was being told. And I just had to say that. It just gets me upset a little bit sometimes. But so they said, okay, instead of the objects moving apart at millions of times the speed of light, why don't we just invoke the speed of light moving very fast? So hence there's a Wikipedia entry on this, on the variable speed of light. And of course, it's kind of negative because it's on Wikipedia, and the critics can, you know, put all sorts of things and criticize it. There's a way that people have tried to say that you can have variable speed of light in a way that is consistent with relativity, or maybe relativity just gets amended. There is a, let's see if I have it. Do I have to take a mirror? Okay, Zhao Majeho, he was one of the big advocates of this. The reason I'm pointing this out, you could find this on the Cornell archive, New Varying Speed of Light Theories. I'm just going to whip through this. Look at the catalog of recent variable speed of light theories. VSL is very, you have the hard breaking of Lorentz symmetry, bimetric VSL theories, color dependent speed of light, Lorentz invariant VSL theories, string M theory effects, field theory, VSL predictions, hybrids. And so there's not just one variable speed of light theory. Even in the mainstream, there's so many of them, and they're trying to explain the mechanisms. So this is where it starts to get just, you know, starts to get ridiculously complicated to try to sort all this out. But maybe the takeaway is that this is the idea is generating active interest, even in the elite circles of academia, secular academia. And that's why I began to be open to it. because I said, if people that smart are exploring it and they're doing it for a reason, and certainly not to solve the young Earth creationist problems, I said, then, this is something I want to look into. And so what have I found? I had,
Sal,
yes,
Sal,
go on.
when you study photonics, will this also be, also, if you study photonics, is that also a part of what you're looking into, or is that a different field of knowledge?
It's actually going to be a different field of knowledge, because I'm going to look at photonics from kind of traditional things of electromagnetism, because the main reason I'm interested in photonics is to see if a redshift could be induced by electrons. We know it can be in what we call Compton scattering, but now I'm finding all sorts of mechanisms like Stark broadening. You actually get a red and a blue shift, but that's if you have a stationary, like a fixed source for your electromagnetic field. So if you have electric field. If you have an electric field and you fire a photon at it, it can induce either a blue or a red shift, I only learned that just like this morning. But if your source of the electric field is itself movable, meaning as the photon approaches, it'll start to exchange momentum with and dump off some of its momentum energy onto the electrons that are generating the electric field, then you might get a net redshift. And so now I started writing plasma physicists to find out. So that'll be my study in photonics if I pursue that. So this whole thing of variable speed of light is just going to add a new complication to it all. So I'm going to show something I was working on just kind of related to this. So I talked about Lorentz. I'll show a little bit of the math that I was, that's Lorentz. He won the Nobel Prize, and a lot of people don't know that time dilation is really his formula, not Einstein's. His was before Einstein's. So when we have time dilation, we use the Lorentz transformation factor. It comes from Lorentz. And let me see, I had tried to, so I'm trying to I'm doing these exercises where I go through electromagnetic theory. And this is the electromagnetic wave equation. So one of the solutions to Maxwell's equations is an ugly differential equation, and you can extract from that what they call the D'Alembertian. And so you could actually go from Maxwell's equations and demonstrate, and I'm showing the proof here of how you can get time dilation. And it was a miserable proof. My first day in graduate school, that was what the professor assigned. Now, he helped us out so that all we had to do is just do the calculus. He didn't expect us to take Maxwell's equations and derive this. That would take months. He said, okay, just start from this one, from the D'Alembertian, and you could show that you get time dilation and all these relativistic effects if you assume that electromagnetism is described by Maxwell's equations. But I talked about my views with this called the neo-Lorentzian view. I'm going to just show a picture here. You can see Albert Einstein here, and right beside him is Lorentz. So a lot of people don't realize that there are other forms of relativity than Einstein's. There is Einstein's theory and then Lorentz's theory. And as far as special relativity goes, all of the experiments are consistent with either Lorentz or Einstein. I think there's one experiment that hasn't been run for reasons that's probably difficult, that would distinguish the two. I think I found an experiment that shows it, and it had to do with looking back at the Michelson-Morley Interferometer. So I'm going to pause here because I just threw out a lot. And if you wanted to have any comments or questions, I'll do my best.
Yeah, that's a bit above my pay grade, those kind of things.
Let me see. Let me look at this. Reginald, I'm going to go, and I should put this, I'm going to put this in this side chat. DeWitt. Okay, so there is a professor, and I've been in contact with him. I think he's a retired professor of physics at a respectable university, Flinders University, Reginald Cahill. He builds interferometers. He's analyzed the infamous Michelson-Morley interferometer, or famous. Okay, depending on what side of the issue you're on. If you're on the side of Einstein, you'd call it the famous one, the Michelson-Morley Interferometer. Albert Michelson won the Nobel Prize for his Michelson-Morley Interferometer. He was looking for the ether, and he failed to find it. And they said, well, okay, that wasn't exactly what you wanted, but still that was a big contribution to science. Here's a Nobel Prize. So his experiment, the desired result of his experiment actually failed, and they gave him a Nobel Prize for it. How's that, huh?
Yeah, and I think in the science, the positive results are a bit over, or at least perhaps not in the Nobel Prizes, but like in the papers, the negative result should be also shown, should be also represented equally, at least, because you need to know what doesn't work, that you don't reproduce it.
So this is where the textbooks claim that the Michelson-Morley interferometer absolutely proved that the ether doesn't exist. And it's a little bit more subtle than that. So here is the Michelson-Morley experiment. And this will relate to variable speed of light. It's just a lot of things to connect. So that's the apparatus there. And so you're asking me yesterday about, a couple of days ago about that, thing with the mirrors. And it's like, no, I don't know about that. And it's like, it's this one you're talking about. And I've also built a laser interferometer to kind of do the same thing. I got inconclusive results, but this one won the Nobel Prize. So I'll just read the opening. The Michelson-Morley experiment was an attempt to detect the existence of the luminiferous ether, a supposed medium permeating space that was thought to be the carrier of light waves. The experiment was performed between April and July 1887 by Michelson and Northwestern Reserve University in Cleveland, Ohio. I didn't know that. So he won the Nobel Prize for that. But it's more subtle than that. Someone went back by the name of Cahill, and he said, well, his interferometer actually did detect traces of the ether if the interferometer allowed air in it. Air is a refractive medium. And someone by the name of Demjanov started to build Michelson-Morley interferometers that had like glass or air or something. I like the ones with glass. And he claims to have detected ether movement. And then Cahill was building interferometers that used glass. I built an interferometer that was, I took the specification of Cahill's interferometer. I bought the parts. It's about $3,000 worth of parts. I assembled the interferometer. I got inconclusive results. I wasn't able to detect the ether, but I did build a pretty good interferometer. And you could look this up. He gives the specifications on how to construct it, and he describes the results he got. I contacted him and said, hey, I can't get temperature stabilization. This thing's going all over the place. He said, oh, I've forgotten how I did that one. Here, try this new experiment. And I was like, oh, I need one of those LaCroix oscilloscopes. And some of them run for $500,000. I'm just like, yeah, I'm not going to be able to do that experiment anytime soon. I could probably rent time on it, you know, but I wouldn't buy one. That's almost the cost of my house. But anyway, so I'm going to point to an experiment that's a little bit more understandable than an interferometry experiment. So what an interferometer experiment, you can either detect changes in light waves or time of arrival with an interferometer, all sorts of things you could do with an interferometer. And one reason we'd use an interferometer is, you know, in the absence of a very precise clock like a cesium beam atomic clock, if you could set up an experiment that does it in terms of interferometry, you can actually measure slight changes without actually having a physical clock. And that's a nice feature of an interferometer. But there was one time someone had a physical clock. And so he describes it here. So Cahill reviewed the data, and then this one. Okay, so I'll just read it. In 1991, Roland DeWitt carried out an experiment in Brussels in which variations in one-way speed of RF, that's radio frequency, of RF waves through a coaxial cable were recorded over 178 days. The data from this experiment shows that DeWitt had detected absolute motion of the Earth through space, as had 6 earlier experiments, beginning with the Michelson-Morley Experiment of 1887. That's the one that had air, not the vacuum interferometer, the one that had air in it. His results are in excellent agreement with the extensive data from Miller 1925-26, which is another interferometer. Data from Miller 1925-26, detection of absolute motion using a gas mode Michelson interferometer atop Mount Wilson, California. The DeWitt data reveals turbulence in the flow, which amounted to the detection of gravitational waves. Similar effects were also seen by Miller and by Torr and Colin in their coaxial cable experiment. Here we bring together what is known about the DeWitt experiment. So there's Roland DeWitt. Let me see, because this is like a lot of papers, it's long, and I don't want to torture people with it in this show. I might torture people in another show because I do nerd torture sessions. So ether. I'll tell you a little more about the ether in a little bit. So they actually had 6 atomic, it looks like 6 atomic clocks in 2 clusters. The coaxial cables were laid out a mile across. And basically the experiment was, let me shrink this. Because you have precise clocks, you could tell how long it took the signal to go from one point to another. And the intent was not to measure a one-way speed of light. It was meant, they're actually just trying to synchronize their communication hardware. So this is one of those accidental discoveries. And this is not the same as Jason Lyle's one-way speed of light. Okay. What would happen is he was noticing that one path, the time of travel was shorter, which means it's faster the other path than the other path. So he had these paired coaxial, 2 coaxial cables side by side and insulated, laid out between these 2 buildings about a mile apart. And so he was just trying to test the synchronization, and he realized, oh boy, the signal's faster in this one path than the return path. And he noticed that the speed would change depending on the time of day. So in Jason Lyle's model, it doesn't change depending on the time of day, but this one changed on the time of day. And in what Cahill had analyzed is the change in the speed. So here there's no difference. When it gets to like 0, that means the time of travel is the same. The time of travel is the same on both optical wires. Since you're going into photonics, it's just funny to call glass a wire. Okay, so but in this case, these were RF. It said RF, I'm sorry. These were coaxial cables, your basic coaxial cable that are like metal, you know, probably copper. So depending on the time of day, you know, one is faster than the other. And it
Do you know
followed,
how much the variation was? Like, was it 1% or 1 part per million,
it was
faster or
very small.
slower?
So
Yeah.
it's a matter of nanoseconds. So it's not very much.
Yeah, but
So,
the
I'll
speed,
tell you what it
the
is. I have to figure. Hang on, can you give me a moment?
Mhm.
Because the motion they detected was the Earth's rotation and through space. It'd be on the order of 300 miles per hour. So we're looking at 0.1%.
Mhm.
300 miles an hour. Oh, wait, I'm sorry. Hang on. No, that's totally wrong. Because that's miles per hour, and I could be way off. So maybe 1 part in a million to, I haven't read it. Maybe a part in a million to maybe 0.1%. I don't know. But the paper's there. I just dropped it in the chat. So he was able to do what the Michelson-Morley Interferometer attempted to do. And the difference between Michelson-Morley, the very first experiment, was they had air as the conducting medium, air in the space. This one was copper, which has properties. And so some of the other interferometers that used like a conducting mechanism like glass, Cahill goes into the theory why this would actually do a better job of detecting it. And that goes into some really strange stuff with electromagnetism, a little bit of photonics. But I look at this, I'm like, well, that's kind of hard to run away from. That may not agree with what Einstein wanted, but I can't run away from this. And if anyone really wanted to test this, they could. So what Cahill did was he started to build similar apparatus over shorter lengths. And instead of using an atomic clock, he used interferometric techniques. And the cost of his various techniques vary. I took the cheapest one, and that was the one that didn't work. It didn't prove or refute. I just couldn't get it to work, and I did write to him. And he said, try putting in a nice bath. And I'm like, I did that, and it stabilized it, but I'm like, I don't know. I still have the equipment. I'd like to run the experiment again. But then, I'd really want to get a hold of that LaCroix oscilloscope. That it uses a funny sampling technique that over many samples, you can actually detect picosecond differences. It's like a picosecond clock. And I'm like, oh, wow. So if you're ever able to get a hold of a LaCroix system, I would be very curious if you could run the experiment, because the device he uses, surprisingly, was just made of diodes and resistors and a AA battery. But the hard part of the experiment is the LaCroix, the LaCroix oscilloscope. So, so that's basically, okay, so that if you have the ether, that doesn't solve the young Earth creation problem, but it does show maybe our understanding of relativity is not what we think. And I was going to revisit the ether because in quantum mechanics, a lot of people don't know this, and for the big fans of someone called Sabine Hossenfelder, or however you pronounce your name, there is something called, and I saw this when I was studying general relativity.
Does Sabine Hoffensfelder or whatever, does she have a YouTube channel?
Yes.
I think I saw 1 or 2 videos of her.
Okay, so she recently gave a video on the problem with general relativity, and I don't know. If someone in the side chat would like to provide that video, a link to it, where she just describes that there's a problem with general relativity. I just wanted to point that out because I saw it in my textbook when I was studying it. So it's like, okay, we do Newtonian mechanics. We know it has its limits. But we'll learn it anyway because mathematically, for certain applications, it's good enough, and you're able to do adequately accurate calculations for your engineering applications. There's no need to invoke quantum mechanics and relativity. So in my textbook on relativity, it said these are the places where relativity will fail. She identified it exactly there in her video and added one other thing, which is called the time problem. And you can see the Wikipedia entry on this. I'm going to put it up. And this relates to, again, why I'm in favor of the ether. It's called the problem of time. So let me just put this in the video, in the side chat here. The problem of time. So I'm having a lot of fun. You know, because you're here, I have an audience for someone that might be even remotely interested in this. A lot of people in the young earth side on creation, they love talking about theology. I'm not a theologian. I like talking more about this. So it says here, so that's the Wikipedia. It says, in theoretical physics, okay, I'm sorry. I keep forgetting sometimes what you all can see. So here it is, the problem of time. And there's a little qualifier here. The article needs attention from an expert in physics. Okay, so just accept this, but Sabine Hossenfelder covered it. And so Patrick Alexander, let me see. Is that the
video.
Okay.
Is Einstein wrong?
Yeah, how we know Einstein's general relativity can't be quite right. Okay, thank you. How do you pronounce, since you can speak German fluently, how would you pronounce that name? Hossenfelder? Hossenfelder.
Wait a second, I want to open it. I would say Sabine Hossenfelder, but yeah.
Well, it's beautiful to hear someone who can speak the native language the way it's supposed to be said.
Is she German?
Yeah.
Okay.
Yeah, I love the German language. Just the sound of it. It's beautiful to my ears. French and German. It's my native language of Tagalog that I actually don't like listening to.
Why don't people, like I hear a lot of German-speaking people who complain that German is an ugly language.
Oh, to my ears, it's so good.
They prefer like Spanish or stuff like this.
I guess to each their own. So in theoretical physics, the problem of time is a conceptual conflict between general relativity and quantum mechanics, in that quantum mechanics regards the flow of time as universal and absolute, whereas general relativity regards the flow of time as malleable and relative. So we keep hearing about time dilation. So in quantum mechanics, one way to resolve this for quantum mechanics is that time is absolute, but our clocks slow down. I kind of like that one better than time being malleable. I'd like to think that there is an absolute truth of what time it is, but maybe our clocks get out of whack. And that's kind of my view. How does this relate to the ether? There's something called the 0 point energy. And it's kind of like this quantum foam that's just like all over the place that pervades space. And they're trying to formulate theories of how light is propagated through this quantum foam. So if that foam can be changed in density, then you can vary the speed of light. I saw only one passing paper, kind of as a speculation, that changing the density of if there's any mechanism that changes the density of the 0 point energy, you can change the speed of light. So that's about all where I am. I'm not saying that I know anything, but I think it would be interesting if we could first of all find out that the ether exists. So they're thinking that the 0 point energy is the ether. So the idea of the ether has kind of come back because of 0 point energy. So let me see if I could find that 0 point energy and 0 point energy. Experiments have, let me see if I could find it. So when I studied quantum mechanics, I don't think I got anything about the 0 point energy, at least in the class. It might have been the textbook, but I didn't look at this. I didn't look at it in that class. So I'll just read this. The 0 point energy is the lowest possible energy that a quantum mechanical system may have. Unlike in classical mechanics, quantum systems constantly fluctuate in their low energy state, as described by the Heisenberg uncertainty principle. Therefore, even at absolute 0, atoms and molecules retain some vibrational motion. And they said something called like a 0 point field. Said all these fields have a 0 point energy. These fluctuating, I'm going to highlight it. These fluctuating 0 point fields lead to a kind of reintroduction of an ether in physics. So this wasn't something that I came up on my own. It's floating around in physics circles, and there it is right there in Wikipedia. So that's why I think it could be a new day as far as this aspect of physics. I will point out GPS, people cite that as being proof of general relativity, but there's something, and you'll love this since you're a fellow electrical engineer. An electrical engineer had participated in the development of the GPS. His name was Ron Hatch. He was also a physics guy. They wouldn't award him a PhD because of some of his views, I guess, possibly around relativity. He's certainly smart enough. And for the GPS to work, he wrote a program to get it to do its thing, and it's called the Hatch filter. It's the Hatch filter. It's in all the GPS systems. It won't work without the Hatch filter. And I remember Dr. Sanford came to my house, and I was telling him, I showed him the interferometer I built. I said, Dr. Sanford, I know you want me to do biology. I said, on my own time, I was so fascinated by this, I built this interferometer. And he said, you need to talk to Ron Hatch. He's on the GPS Council, the government council, congressionally authorized or whatever. And I'm like, how could he do that? He doesn't believe in general relativity of Einstein. He's what they call a neo-Lorentzian, like I am, a neo-Lorentzian relativist, not an Einsteinian. And I'm like, how did he get there? And Dr. Sanford said, well, he invented something that makes the GPS satellites work. And I got really interested. And then I saw a picture of all the people on the GPS Council and their names. Two of them were one of them was my boss above bosses at the MITRE Corporation, Marty Faga, and then one other MITRE guy. And I'm like, this is feeling like kind of close to home. So we have someone who made the GPS work who didn't believe in Einstein's version of general relativity. He believed in the Lorentz ether one. So this is why, some people say it's all settled. And I'm like, I don't think so. There's some really good, there's a minority of really smart people that have made devices that are like the GPS that are relevant, that wouldn't agree that that it's a complete theory. As Hossenfelder said, Einstein's general relativity can't be quite right. It's not like it's totally wrong. It can't be quite right. And that might be like the little crack that the young Earth creationists are hoping to go through. So
Mhm.
that's mostly what I had to say. The Council of GPS Elders.
And what would you say? To me, it sounds a bit like the theory is generally correct, but there are some things, some small inconsistencies. But if the universe was young, then a few small inconsistencies wouldn't be enough because there would be quite a lot of change, and a small inconsistency obviously can point to big problems because I don't know how much of the general relativity is built on assumptions of certain facts and how much it is actually. Yeah, basically all theories just are models, mathematical models, which try to represent what is happening in reality. So there can be two completely contradicting models, which both represent all the known facts. And so, how much is the so I think it is possible that small inconsistency can point to that the old Earth is wrong. But how much would you say is this a fact that or how for me it sounds like this is a small crack, but it's not one which can blow away the entire old Earth. And
Yeah, I would agree with you. So
Mhm.
it just occurred to me when you ask, what's the difference? I said maybe 1%. Okay, so let's say, we're looking at stars that are a billion light years
Yeah,
away, or 14.1% is like not going to
yeah,
solve it down to 6,000 years. So I think
yeah,
that's your sentiment, and that's my
yes,
concern too. So the hope is um, that however the ether, this is how it would have to be as far as this theory, this speculation of mine, that the properties of space local to the solar system would have to be very different than those between stars.
hmm,
And there's no way to prove that right now. But
yes,
the idea, this is the only way that I could see that it could work. Uh, that little crack here is a lot bigger out there, and I don't know how we could, you know, it's in
I
theory
think,
we might be able to build a spacecraft, but I'll be dead by the time they get it out that
yeah,
far.
yeah. So yeah, that's certainly a possibility. But yeah, it's more like a glimmer of hopes, not a clear path.
Yes, and so this is why, and I get a lot of grief from my fellow young Earth creationists. I said the old Earth model has a lot of merit to it. That's one of them, just for what you just said. And I just to bring up that, well, I took down that list of all the
Mark
young Earth cosmologies. I'm sorry.
Mark O'Connell Connell said something, or at one time different, and I think it is a fair point that during Paradise and after Paradise, the laws of physics could have changed, and if the laws of physics changed, then that would be another option instead of just inside the solar system and outside between stars. So
Yeah.
I think that's a fair point.
So if I might say this, um, independent of young Earth creationism, I think the Big Bang is in big trouble.
Mhm.
Because I began to get hints of it 20 years ago from the faculty at my own school, from secular faculty. And I listed their names: Mina Skafatos, Cicero Roy, Malabika Roy, and kind of in between would be James Treffel, who was my professor. And that has to have an effect on students who are at a university when they see professors openly protesting, not just quietly dissenting. They were writing letters and saying, "We dissent." You know, is this one called Cosmology Statement. Let me see if I have it here. Yeah, open letter. This is the letter that my professors signed. And these are secular professors. Open letter on cosmology, open letter to the scientific community. And it was signed by those professors, and they're talking about why they didn't like the Big Bang. Let me put this in the chat, in the side chat. So like I said, this as someone that was pondering all this, I said that, you know, that had influence on me, because then I didn't feel so out, you know, I didn't feel so out and left, you know, so far out of the mainstream, at least on the question of the Big Bang, because I see these secular professors, including mine, that were raising concerns about it. So I think probably the thing young Earth creationists can look can consider is whether they can get falsification of the Big Bang. Now that may or may not help the young Earth case, but I think at this point the young Earth creationists will be happy for a little bit of anarchy, just to show that the mainstream can get it really wrong.
I think that would actually help the atheists, because as far as I'm aware, they're always fighting for an eternal universe. So
yes,
that would they would probably think, see, God can't the God can't have started the universe, therefore God, one of the main arguments for God falls away. So I think that would be the argument of them.
You're exactly right. So this is a strange situation where we have the young Earth creationists and the diehard atheists being on the same team. And then on the other side would be the old Earth creationists like Hugh Ross and others. So this is kind of a very strange fight where kind of the alliances kind of regroup.
I don't think that the atheists would consider the young Earth creationist as an ally, because the way I know them, they would say, "Yeah, you're comparable to flat Earth, and therefore you are not worth even considering, and it is eternal anyway." So I don't think they would consider. I don't consider that as an allyship, alliance.
Yeah, I think you're right. Literally speaking, I was more or less saying figuratively. We're common foes. We have a common foe is probably the better. We have a common foe in taking down the Big Bang. But there's one thing we have that would still be difficult for them to explain. The stars can't be burning forever.
Yeah.
And so,
here I have. I said last time that I had a course on cosmology, and there was an astronomer, one teacher, and the other one the head of the Department of Religion. And there they mentioned that space might be infinitely expanding, but whenever it expands, it creates matter during expansion. And because of that, I don't know where basically, if the universe has a beginning, then at some point there is a heat death and everything turns into radiation. And I don't know how that would mean basically that the radiation would increase, or I don't know. But I think they would want to invent spontaneous creation of matter while space is expanding, or something like this.
it was interesting because in my book on cosmology, it was between the steady staters and then the Big Bang. The critics of the steady state said it's outrageous that you're creating matter kind of continuously. I don't know the reason for that. And then the steady stater said, well, how's that any more outrageous than assuming all matter is created in a Big Bang? So, and there are all sorts of oddities in the Big Bang. I don't explore too much. That may talk about like creating potential energy, because now you have two gravitational bodies, just having more distance between them. That would create potential energy, and we know energy is like matter, and just like I don't know what to do about that. So I think from just the standpoint of anarchy, if there's anarchy in physics, then the young Earth creationists would like that, because then they would feel then that as long as we don't have theories set in stone anymore, then it opens the path for other theories to be put forward. But I think the distant starlight problem is going to be very, very hard to resolve without a miracle of God. And I think one of the big miracles that I'm counting on is that toward the end of the world before Christ returns is that passage in Revelation 6 where it says the stars will fall toward the earth. And granted, other people have other interpretations of what that means, but to me, that would be a good confirmation of young Earth creationism if we saw that.
I just thought of something. I think the young Earth creationists would love it for me, I was like, yeah, but it doesn't really, even if the Big Bang isn't true, it doesn't really disprove anything about the age of the universe. But
Right.
most people are not like the people here. They are less interested in the full discussion. So I think the young Earth creationists, which are more on the Cantoan level, they would be very skilled in using that in reaching the masses, even though it's not actually true.
That is correct. That is correct. I think the only reason I think that they would want to just take down the Big Bang is just to say, hey, look, you can't trust mainstream science, just trust the Bible, which
Yeah.
isn't exactly a logical argument, but that's kind of the sentiment of where they're going. But we have, we cover the nuances here.
Mhm.
I got to confess, this has been on my mind, and at least taking down the Big Bang, because I think the theory has a lot of problems, and if we have a bad theory, that keeps being recirculated, it starts to impede future discoveries, and I think at this, it really runs the risk of falling apart as a theory, because I've around some of the graduate students here in the USA that I've been around, they just kind of shake their head. It's like, it can't possibly be right. And so you had everything, the popularizers and the big name scientists supporting the Big Bang, but the next generation is skeptical. I find that compelling.
Mhm.
So anyway, I'd like to thank everyone who's here, and if you had any closing thoughts, we're at about the hour 45-minute mark. If you had any other thoughts that you wanted to share, or comments or questions.
No, it was interesting. And I think I understand your position better on it and the young Earth creation position in general. So, yeah, it was helpful, beneficial.
Oh, and I promised I'd mention this since it's in the title about control theory and evolution. So just really briefly, Benrex said if he's considering control theory and seeing how evolution squares with that. So in control theory, a very simple example of a control system is your thermostat. So you set the thermostat at a particular temperature, and it'll turn on the heat pumps or air conditioners or heaters at the appropriate time at the temperatures deviating. So how it's a feedback control system. So it senses something is not quite right, and that's what we call an error signal. And so some very sophisticated control systems is if the error is really big, you put a lot more compensation. So like, let's say you have a motor, and now it's, the motor's having to work a little harder, so you put more electricity in it. Lawnmowers, even something as simple as a lawnmower has a governor system, so that when you're hitting tall grass, it's going to start to kind of press on the, add more gas automatically. And so they developed this thing called control theory, so that if there's a goal, like say a desired outcome like temperature, or like say a missile homing in on a target, it's always processing these error signals. And natural selection, like in Dawkins's book, The Blind Watchmaker, it's kind of a control theory like viewpoint. Like you have this target string, which could correspond to a protein, and he uses it, methinks it like a weasel, that phrase. And you have this random string, and it's compared against the desired target, and when it's off, you just do some random mutation and you save the ones that are closer to reaching that target. That's a very control theory like approach to how they believe evolution works. But when we actually look at how biology works, that's where the creationists say, no, even the evolutionists say, well, no, there's no target that it's searching for. And that's, just kind of considering these things, the one question is, would evolution have to work like a control theory, like a system of, control circuit? And I'll just leave it at that, because Benrex said he hasn't developed the theory very much, but I wanted to give you some pointers. And I will point out one thing that a paper had realized is that if you have competing constraints, it's very nice if you have only one constraint to satisfy, like temperature. But let's say you have two competing constraints that are actually in conflict. You could get a situation where neither target is hit. So let's say, you have a missile and it has two targets, and simultaneously you have one control system that's trying to make the missile hit one target and the other try to hit the other target. Well, then you might end up missing it. There have been situations in population genetics, like in that paper that chapter I did with Dr. Sanford, that's a reference work in Springer Nature. There are situations where you have that, where a quote unquote desired target, neither of them is actually achieved.
If I'm not mistaken, then the target might be to get as many offsprings as possible to replace all the others. That's basically the target, if I'm not mistaken. But that would be there would be a problem which you already mentioned, that complexity doesn't really have much influence in that control system, and because of that, it's either ignored or optimized away so that it's not there anymore. So yeah.
Oh, I just realized, here's a good example also. Let's say you have two individuals. One's very smart, he's very smart, but he's not very fast. Then you have the other individual, he's very fast, but he's not very smart. It'd be desirable to have the species be both smart and fast. But here are these two individuals, these two guys walking along. One's smart, very smart, but not very fast. The other one's very fast, but not very smart. A lion comes along. The very fast one will run away, and the lion eats the very smart guy. And this is kind of, Dr. Sanford and others have said, yeah, that's kind of problematic for natural selection, where selection might actually select for something, and in the process eliminate a good trait out of the population. And like, yeah, we're seeing that all the time. So that is where biology may not fit the control model, because you don't get a very helpful error signal, because you're not able to get a situation where you can preserve both traits. You can hit two targets simultaneously.
I would
And
word it different. The word, what you said, it doesn't fit the control model is a wrong statement because everything fits the control model. But if you simulate it in a control model, you might detect that it is a pretty inefficient control system. I would say
oh,
it
okay,
in that way.
okay.
But
Well,
yeah.
I figured I'd just pass on some of my thoughts, from
Mhm.
electrical engineer to electrical engineer. And it's great hanging out with you, because this was
I-
from like my life 20 years ago. And I've
yeah.
since turned into biology.
Yeah, I can also give a um, quick description of my plans. I think that would be helpful. Um, I as a in my bachelor in electrical engineering, I had a few topics that I focused on, and one is control theory, and mostly because control theory is it's basically everywhere, and it's very powerful. And so I thought, yeah, it's just interesting also to me. And in my current job, I never used it so far, but that doesn't really matter. But now, when I heard about the theory of evolution and that this should be an anti-fragile system. With anti-fragile, I mean a system which gets stronger when it is under pressure. So basically, when there is a selection pressure, the creature evolves to be stronger afterwards, and stronger in biological terms is more complex and more flexible and more whatever. Um, to me, that doesn't really add up when I look what the control system is, like the feedback loops and everything. And it is a intuitive problem I have with this entire thing. So with the theory of evolution, and I'm not 100% sure if I actually if I actually look at the right thing, because yeah, intuition can be correct or it can be wrong. And so now I'm currently reading up on my control theory stuff again. And then I want to present here. First, I want to give a solid explanation on control theory here. This might take more than one stream, probably will take more than one stream. But after I explain control theory, then I will go into why I think that evolution is not actually an anti-fragile system. Why it can't develop, or why it is very unlikely that it will develop positive, more complexity. And so that's my goal. And yeah, I don't know. It's a quite a big task, so it won't be next weekend that I'm ready. So it might be in a few months. But that's my plan to refresh everything, put everything into good slides, and then prepare a bit that I can present it in a way. Then Sal can obviously ask questions, and the audience as well. That's my goal.
Oh, that would be wonderful, because a lot of people like me came from engineering backgrounds, and then we started to immigrate into the biology realm. So, so you're kind of following that now. And
But I don't think I will go into the biology realm. It's more like I take a peek over there and see they do something which contradicts 101 of my field. So that's more how I look at it. And I think it is generally helpful to learn new stuff. And so that's why I want to not just give the argument, because for people who have no background in it, they won't understand the argument. That's why I want to give enough background to the people who listen to this to these streams, then that they can actually understand the argument. That is my goal.
Oh, that'd be great. And there is a joke. Can a biologist fix a there's been an ongoing joke, because engineers have their schematics and they can compare what's right and wrong. They're able to fix things like radios. Biologists don't have that luxury because they don't really understand the purpose and the design. We have only hints, and so there's this funny thing here. Can a biologist fix a radio? And there are various implementations of this graph where they talk about their approach. Can a biologist fix a radio? And so okay, so let's say we have a biologist fix a radio. So what does he do? He says the first step is obtain grants to purchase large number of functioning radios. Perform a comparative analysis. Take out all the pieces, classify them, and give them names. Begin genetic analysis by bombarding functioning radios with small metal objects. Misfunctioning radios will display phenotypes. But there's actually a grain of truth. This is how they do biology, because they don't have the schematics handed to them and all the theory that tells them how it's put together. This is why when I went into the biology world, I was just so shocked, because fixing a radio would be like finding cures for cancer. We really don't know how it's supposed. We don't know exactly how it's supposed to be built, and we don't know the techniques. Even if we knew what had to be fixed, we don't know how to actually do it. So I just found this was funny.
Yeah.
And so when the engineers enter their world, it's just a shock for them. I'm sorry, go on.
Yeah, I also know a joke about the different fields. Like a mathematician, a physics professor, and a biologist, they observe a bus on a bus station, and then they see 10 kids go into the bus. And then at the next station, they are there again for some reason, and they see 11 kids going out of the bus. Then the biologist says, oh, they must have reproduced. The physics professor says, yeah, 10% tolerance, that's perfectly fine. And the mathematician says that, oh, now one kid has to go into the bus that there is none in there.
Very good. Well, I'll give you the last word. And thank you for joining. And thanks to all the audience. If you have any closing thoughts.
No, I already gave them. It was a beneficial stream. Now I have a better overview. And yeah, it was fun talking to you. And yeah, that's already everything.
Well, and likewise. So everyone, take care and God bless you. Have a great afternoon.